All right, let's go to the right answers to the simulation. I hope you enjoyed doing the simulation. I think it's kind of a neat way of actually seeing some of this stuff happen, and it's easy to set up for yourself. So the one we're looking at is this worksheet, which has the little spinning wheel on it and stuff. So when you look at the very first one, said in the picture, energy is being converted to heat water. What type of energy transformations take place in this model? Well, so the first thing, you've got mechanical energy. That's the wheel going around, right? And then after that, then it changes it into electrical energy, right? Which basically runs some power over to the little heater thing, and then it turns it into thermal energy. So for that very first one, you should have mechanical, the wheel going around, electrical, the energy going across, it's producing electrical energy, and then thermal, which is heat. So you're heating up the water. Second one in the picture, energy is being converted to heat water. What type of energy transformations take place in this one? Well, this one, number 2, we've got a solar panel. So light is shining down on the solar panel, so that is light energy or radiant energy. That turns into electrical energy. And then the electrical energy turns into thermal energy to heat the water. Oh, hey, that's almost the same as the last one, except we had mechanical energy to start with. This time we have radiant energy or light energy to start it off with. So if you watch when you're driving around the county, you should notice that we're getting more and more solar panels popping up all over the place. I'm looking into trying to put some around my house to try and collect some of the solar energy. And then I can actually basically take that solar energy and I can sell it to the power company so that it can go out and help everybody else around me have energy, and it doesn't pollute the environment. So, all right, well, letter B, it says, what happens to the energy transferred when you have lots of clouds? Well, that is, concern, because for myself, if I have lots of clouds, is the light going to shine down on my solar panels that I want to have put up? No, it's going to decrease the light, so therefore it's going to decrease the amount of electricity, which will decrease the amount of thermal energy going into that water tank on there. But hopefully what it does is it kind of like balances out. Some days it'll be really light out, I'll get lots of energy. Days when it's cloudy, not so much energy. But hopefully somebody else that has solar panels gets light, and they're going to be able to put energy into the power grid. Number 3, it says in the picture below, energy is being converted to heat water. What type of energy transformations take place? So this one, just so you know where we're at, we're on number 3, so we got this, right? So in this one, we've got thermal energy. We've got heat underneath that little tea kettle. That tea kettle then is producing steam, which is going up and making the little thing spin around in circles. Because it's spinning around in a circle, that's mechanical energy. And then that mechanical energy then turns and makes electrical energy. So we got electrical energy going up the wire over to the tank. And then that tank is then getting heated, so that's thermal energy. So we're going thermal to mechanical to electrical to thermal are the 4 things. All right, then we go to question number 4. We got the girl, it looks like a girl that's riding a bicycle. So on that one, we're going to start off with the girl. She's sitting there like riding a bike like crazy. Well, how did she get energy to start with? Oh, that's right. She had to eat breakfast, lunch, or dinner. And that breakfast, lunch, or dinner, that's chemical energy. So we're going to start with chemical energy on her. And then while she's riding the bike, she's producing mechanical energy by making the wheel go around, which then goes up and runs the wheel in the center. That wheel then runs a generator, which produces electrical energy. And then that electrical energy then goes over and heats the water, and we get thermal energy. So we got chemical, mechanical, electrical, thermal. Now remember, the whole idea on this whole thing is what we talked about in the notes beforehand, and what's coming up later, and that is we're just changing energy from one form to another constantly. Right? So letter B, what kind of energy is converted to waste energy by the bicycle? Oh, waste energy. The waste energy is thermal energy, all right? And we get some heat that's given off, so we lose some energy due to heat. It isn't destroyed. All we simply do is lose it into the atmosphere, and it goes floating off into the atmosphere. What force is causing this wasted energy? The ever-dreaded friction. Friction causes us to lose energy. If we can reduce that friction, if we can take that bicycle and oil up the chain and oil up the wheels and the bearings and everything, that'll make it so we reduce that friction and we get more energy out of it. We don't lose as much to friction or heat. All right, question number 5. In the picture below, energy is being converted to a light bulb. Oh, we're changing it to a light bulb now instead of heating water. So we got the water coming off the top, that's mechanical energy, and it's turning the wheel going around. Okay? The wheel then produces electrical energy. The electrical energy goes over to the light bulb, and it produces two things. It produces thermal, because the light bulb gives off some heat. If you've ever unfortunately grabbed a light bulb when it was on and tried to unscrew it, you burn your hand because it is actually giving off some heat. And we also get radiant or light energy produced. So we get mechanical to electrical to thermal to radiant. What kind of energy is converted to waste energy from the bulb? Well, what do we lose? We lose it in the form of thermal. So if we can get light bulbs that don't produce heat or produce very little heat, then we get more energy out of it. And one of the latest things right now is LEDs. And that LED actually stands for light emitting diode, LED. And LEDs actually don't produce a whole lot of heat. They produce very little heat. So actually we get almost all the energy that goes into it comes out as radiant energy. All right, so we get it increases the efficiency or the how much energy we get out of that to do what we want it to do, and that is light something up. All right, number 6. Energy is being converted to a light bulb. What type of energy transformations take place? So this time we got the little kettle that's being heated. So that means if it's being heated, then we've got thermal energy to start with. That thermal energy goes up, runs the little thing going around in a circle. That's mechanical energy. That then makes the generator go, so we get electrical energy going through the wire. And the wire goes over and lights up the light bulb. So we get light. Okay. Says what kind of energy is converted to waste? Oh, we also didn't have that in there, but we have thermal energy. So we do have some heat that's being produced and given off by the light bulb in this case. Number 7 now. Energy is being converted to a light bulb. What type of energy transformations take place? So we got the girl riding a bicycle again. So the girl riding a bicycle, she ate lunch. So she's got chemical energy in her. Okay. And then she's running her bicycle. That produces mechanical energy, which is the wheel going around, which then produces electrical energy going through the wire, which then goes to the light bulb and gives off light. Oh, hey, there's a different light bulb in that one. What kind of light bulb is that? That's a fluorescent light bulb. Fluorescent light bulbs don't give off as much heat. They give off less heat, so we don't lose as much energy or waste as much energy in the form of thermal energy out there. That then takes us to number 8. It says letter A, what is different about the energy produced between these two bulbs? Well, we got the fluorescent bulb produces less thermal energy than the bulb that's round, which is actually called an incandescent light bulb. Those are getting harder and harder to find now because we aren't producing them because they aren't as efficient. They waste too much energy. So circle the bulb that produces the least amount of waste energy. So you should have circled the fluorescent one. And the fluorescent one is this guy right here. You should have circled him because he produces the least amount of waste. Now we're getting more and more, we're getting to LEDs actually. Number 9, so energy is being converted. This time now we got a fan that's being run. So we got the wheel that goes around because of the water, that's mechanical. That then runs electrical energy going through the wire, which then goes over and runs the fan going around, which that's back to mechanical. So it goes from mechanical to electrical to mechanical. Number 10, now we got the solar panel again. Solar panel, we got light, which is radiant, that's the first part, which then turns into electrical, it goes through the wire, which then runs the fan, which is mechanical. So we've got radiant or light, which turns into electrical, which then runs mechanical. It says, after observing different forms of energy transfer, which form or forms of energy have the least amount of waste? So which ones? Well, you got solar. Solar has very little waste. You should have noticed there's very little waste or heat that comes off that. Then you got another one would be fluorescent. The fluorescent bulbs, those have very little energy that's given off. So, given off, but wasted in the form of heat. So those are the answers to that worksheet. So hopefully you learned something on it. And hopefully someday you can drive by my house, and I hope I can have it happen someday, but I hope that I have some solar panels in my yard. Trying to help with the environment, trying to reduce the amount of pollution that goes into the air, and make it so this world can last longer. All right. So, and hopefully you'll think about that for yourself someday and go, hey, you know what? I should put in some solar panels. Or maybe down the road, maybe we'll come up with even some different types of better sources of energy that we can use that doesn't waste the energy that we try and produce. So something just food for thought to think about. So have a great day. We'll see you another time.